This example is kind of a bit of a reverse of what you've done before, because what we're going to do is try and find constants. So again, we've got a solution or a proposed solution here, which is y e to the 4x 2x plus 1. And we're told this is a solution of y double dash minus a y dash plus by equals 0. I'm just using the dashes here instead of the notation here, just so that you can get used to the fact that they're actually equivalent notations. So you can use either one. Let's move that over a bit. Okay, so what I'm going to do here is, first of all, differentiate. And because we want to differentiate, this is really two functions multiplied together. So it's going to be product rule. So let u equal e to the 4x, b equals 2x plus 1, u dash equals 4e to the 4x, b dash equals 2. The derivative of 2x plus 1 is 2. So our first derivative, y dash equals u dash v. So it would be 4e to the 4x outside of 2x plus 1 plus v dash u, 2e to the 4x. Now with something like this, it's a good idea to take e to the 4x out as a common factor, because it is common in both terms, so you can see there and there. So I'm going to take it out as a common factor, and now in the brackets, 4 times 2x is 8x, 4 times 1 is 4, plus 2. And that's all the stuff that's multiplying e to the 4x. So we'd have y dash equals 8x plus 6 e to the 4x. So that would be our first derivative, and we'd go through and actually do our second derivative in a similar way, because you want to really show your steps here, and you're going to have to use product rule again. So just go up here. So second derivative equals, and again you've got a u dash and a v dash, a u and a v, so u dash v plus v dash u. I'm going to let u equal, we'll make it the linear part this time, just to show it doesn't matter what order that you do this in. V equals e to the 4x, u dash equals 8, v dash equals 4e to the 4x. So we get the second derivative equals u dash v, 8e to the 4x, plus v dash u, 4e to the 4x outside of 8x plus 6. And again, we're going to take e to the 4x out because it is a common factor. It's there and it's here. And so that means taking the 8 as the first thing in the bracket, plus 4 times 8x, which is 32x, plus 4 times 6, which is 24. So we then end up with our second derivative equals e to the 4x outside of 24 plus 8, which is 32, plus 32x, which is quite nice. So we've now got our set, I suppose, of y double dash, and y dash, and we're going to use those on the next page. So what I'm going to do, I'm just going to write those out again so we can see the order of them. So y, the second derivative, and the first derivative, you can see that e to the 4x is common to all of them, and that will always happen when you have exponentials. I'll just copy this now so we can work with it on the next page. And now we're going to look at the verification part of this. We know that y is a solution, so these functions should satisfy our differential equation. So this is the differential equation here. I'll copy this one over. And our job is to try and find a and b. So we'll just put that there. Okay, so we know that this differential equation is satisfied, hence let's do some substitutions. So the second derivative we know is this, minus a times the first derivative, plus v times y. And you can see that e to the 4x is common to everything, as it always will be when you're dealing with exponentials this way. So let's take that out as a common factor. So we've got 32 plus 32x. We've then got minus, and I'll do this actually in blue so you can see, the minus a, so all of this, times 8x, so it's minus 8ax, minus a times 6, so minus 6a, and here we've got plus b times 2x, so plus 2bx, and then plus b times 1, so plus b. And just make this the same colour, move this over. So we're nearly there. And we know that all of this equals 0, because we know our differential equation here equals 0. So now what we need to do is do a bit of simplification in here. First thing that we notice is we've got an exponential times a bracket. Now exponentials can never equal 0, because no matter what you put up here as the value of x, even if you put infinity, it will approach 0 but never be equal to 0. So that implies that the bracket here is what's equal to 0. So 32 plus 32x minus 8ax minus 6a plus 2bx plus b equals 0. And what we can do, because we've got two distinctly different things, we've got constants and we've also got coefficients of x. So I'm just going to write that there. Whoops. Coefs of x. So first thing I'm going to do is look at the constants. And you can see I'll circle those in green. That's a constant. Oops. That's a constant. There's no x there, and that's a constant. So we have 32 minus 6a plus b equals 0. So we end up with, and just rewrite this. Just put all the a's and b's on one side. So we've got, take that over to this side, so we'd have 6a minus b equals 32. So that's our first equation. Our second equation, let's have a look at the coefficients of x. So the x coefs in the equation. You can see here that 32 is a coefficient of x. I'm not going to write the x down because x is common to all the terms, and then you could just divide everything by x. So 32 minus 8a plus 2b equals 0. And again, just going to write that out and make 32, leave that on one side. So we've got 8a, take away 2b equals 32, and we could also divide both sides by 2. So we'd have 4a minus b equals 16. So there are two equations. We're now going to work with those to try and find what a and b are. So I'll just copy that over onto our next slide. Now we can solve these by hand or using the CAS. We'll do it both ways. So first thing I'm going to call this equation 1 and equation 2. So we can see if we take equation 1 and we subtract equation 2, on the left side we would have 6a minus b, and we'd take away 4a minus b. On the right side we'd have 32, and we'd take away 16. So you're taking 32, taking away the 16. So here we'd have 6a minus b minus 4a plus b equals 32, take away 16 is 16. The b's cancel. We have 2a equals 16, so therefore a equals 8. So we found a. You can substitute this back into either of the equation. So I'm going to substitute back into 2. It's got smaller numbers. So 4 times 8 minus b equals 16. 8 fours are 32. B equals 32 minus 16, which equals 16. So therefore, A equals 8 and B equals 16. So in this particular equation, you were given the differential equations. You were also given a solution that satisfied the differential equations. You had to differentiate that solution 2 times and then substitute it into the differential equation, which we knew was satisfied and equaled 0. You then found, by equating constants and coefficients of x, 2 equations to help you find the unknowns a and b. And if you want to do this in your CAS as well, all you would do is put these two equations, equation 1 and equation 2, into your CAS. You can see here we're using the solve command, so we've got solve, our two equations, they're inside a square bracket, separated by a comma, and they're both equations, so we've set them both equal to 0, and then comma A, comma B, because we want to solve for A and for B. And if you push enter, you can get A equals 8 and B equals 16, which is what we found by hand. So the idea here really is to identify, you're trying to find two unknowns, which means you'll need to find two equations to get those unknowns. And we do that by using that solution that was given and then working our way through the problem by finding derivatives and substituting them into the DE.